One. Hi, everyone. Thank you for watching our channel today. Today for our math lesson, we are doing a story problem. And our story problem is about a lot of things that we have seen in the classroom and that we have probably taken because they were distracting you. They're about Pokemon cards. So we're going to have our story problem about Pokemon cards. And while I'm reading the story today, I really want you to really visualize the story. So when I visualize a story, I like to think of the setting and I like to think of what is happening in the environment. So I like to close my eyes and visualize it in my head. So really try to do that so that you can see what's happening and not just hear a story, but you can feel like you're in that story as well, because math has stories. So here we go. See. All right. Rudy and Omar were playing with their Pokemon cards out in the schoolyard. They had Pokemon cards. Pokemon cards flew away. How many Pokemon cards do Rudy and Omar have now? Okay. So by visualizing it, I want us to think about who are the characters and what is happening in this story. Remember, characters are the people the story includes or is about, and what is happening? What are those characters doing? So my friends at home, if you just need a little bit more think time, press pause, but my teachers, they are ready to go. So Miss T, can you tell us who are the characters in this story?
The characters are Rudy and Omar, and it's a sad day for those two because their Pokemon cards got blown away.
Yeah, they flew away, right? So they had Pokemon cards, but then there was a big problem. Ms. Rosales, can you repeat what was the problem?
Their cards got blown away. Blown away.
They flew away. They were blown away.
So they shouldn't have to school.
Yep, that's probably why you shouldn't bring them to school. So now they probably learned better from that experience. So now we're going to look at the problem. We're going to read it for a second time with our numbers. So Ms. Rosales, I know you are really excited about a number set.
Yeah.
What number set would you like us to do today?
Number 2.
Number 2. All right. So I'm going to choose the number 2, just like Ms. Rosales wanted, and we plug in the number. The first number goes in the first blank, 26, and then our second number, 12, goes in the second blank, 12. All right. So now, Ms. Rosales, can you read the story for us with the numbers?
Rudy and Omar were playing with their Pokemon cards out in the schoolyard. They had 26 Pokemon cards. 12 Pokemon cards flew away. How many Pokemon cards do Rudy and Omar have now?
So thinking about this, what does the 26 and 12 mean? So really looking back at this problem, at the story, the numbers have to represent something. So what do they represent in this story? Miss T, what does the number 26 represent?
So 26 are the Pokemon cards that they had to begin with when they're at the schoolyard.
I really appreciate you saying that that's how many Pokemon cards they had to begin with. So when we start this story, there are things happening in the story. And they first had 26 Pokemon cards, but then some flew away. Do we know how many flew away, Ms. Rosales?
12 flew away.
12 flew away. So if they had 26 Pokemon cards first, but then 12 flew away, do they still have 26 Pokemon cards at the end of the story? Why not?
Well, because when something flies away, it's gone.
Right. So they got lost. They're gone. So they don't have 26 anymore. They probably have, and I saw you going like this, Ms. Rosales. What do they have? Less Pokemon cards. So it's not going to be, they're not getting more. They didn't get any more. They actually lost some. So their Pokemon cards are going to be smaller than what they originally had. So let's figure out, what are we trying to solve in this problem? And usually our story problems end with a question. So Ms. Rosales, can you read? What are we trying to figure out?
How many Pokemon cards do Rudy and Omar have now?
Now that some of them flew away, how many do they have left? So really think about this. Is this a subtraction problem or an addition problem? So think about that before you start doing your strategy. So boys and girls and friends at home, you can pause the video now to work on your strategy. And I'm going to give the teachers a little bit of think time and working time. And when they are ready, they're going to put their thumb up. But you can pause the video at home and give yourself as much time as you need to solve the problem, and then play it again when you're ready and you want to check your answers with us. And Ms. Rosales, I'm going to have you go first. So I'm just letting you know ahead of time so that you are prepared. And then Ms. T, you'll go right after.
Yes. I'm ready with one part.
All right. Okay. So I noticed that Ms. Rosales is using a number line strategy, and we have been using a number line strategy yesterday as well. So thank you for that, Ms. Rosales. So I see that you drew the number line with your arrows.
Yes. So I started with 26 here, and I knew that I had to subtract 12 because 12 flew away. And so I decomposed it to a 10 because it's a benchmark number or a friendly number to work with. And I took my 26 and just looking at this tens value, dropped one tens value to 16 and then took away one more for 11 and one more for 12, which left me at 14.
That was so beautifully said, Ms. Rosales. Thank you so much for helping us with that. So you did two types of strategies. You combined decomposing and our number line. So you had 12, and then you decomposed that into a friendlier number, and that's why it's really important that we know what our tens are and getting familiar with those tens. That's why we've been working so hard with tens and ones. So you decompose 12 to make 10 and 2 so that you can subtract first 10 from 26, so subtracting 10 here, and then you subtracted 2 more by ones, right? So you know 1 plus 1 or a 1 plus 1 equals 2, so you actually decompose that even further in your head. And then you got 15 and 14. And that was your answer. Ms. Rosales, can you tell us what equation would you create with this number set?
So just looking at the number line, I would say 26 minus 10 minus 1 minus 1 equals 14.
Beautiful. So we had our 26 that she started with, 26, then she subtracted 10 minus 10, and then she subtracted 1 minus 1, subtracted 1 more, minus 1, and we got a total of 14. So 14 they have left, 14 Pokemon cards left. All right, now let's see Miss T's strategy. Miss T, can you share your strategy with us?
Yeah, so I knew that I had to do a subtraction sentence. So I did 26 minus 12, and I got 26 first because we always start with what we have, and then we take away what left. And so I took away 12 because that's how many cards flew away. And I was like, I can't do it in the horizontal equation. It's too difficult for me. So I put it vertically over here. And so first I subtracted with my ones place. So I knew 6 minus 2 is 4. And I counted that in my head because I memorized my math facts. But boys and girls at home, if you can't remember, you can always use your fingers. Then I went to my tens place and I did 2 minus 1 equals 1. So I know that I had 1 10 left. So that gave me 14. And I wasn't sure because this is my first time using algorithm strategy to subtract. So I drew a direct model on the bottom just to check my work. Because boys and girls at home, we need to be using 2 strategies in our math story problem. So I drew 26 Pokemon cards, and then I crossed out 12. I counted it one at a time, and then I counted how many I had left, and then I had 14.
Beautiful. So I'm trying to replicate your strategy, and I love that you did 2 strategies because that is what we're asking us everyone to do. And we've always asked our friends to make sure that they check their answer using a second strategy. So thank you for that, Ms. T. And it's going to take me a couple of seconds to do the direct modeling. That's why this is probably one of the first strategies that we learn because we usually use it with smaller numbers. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
And that reminds me that this also helps us understand that if direct modeling takes too long, it's probably not a good strategy to use because sometimes we lose count or sometimes we make a mistake. And so like you said, I only use direct model when it's a smaller number because it takes me way too long.
I was about to agree with you, Miss T. I was like, woo, aren't you glad that I didn't pick the last set?
Yeah. So this one's a little bit easier to use direct modeling. If we were to use the last set, it would take a long time. So I have my 26 here, and then what Miss T did is she took away 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then let's check how many we have left. So I know I drew 8 on the top. So 8, 9, 10, 11, 12, 13, 14. So 14, and that is the same answer we have here. So, and that's the same answer that Miss Rosales got. So we must be correct with our strategy. So we're correct and we are accurate and quick. Maybe not the drawing strategy or direct modeling, but that does help us, right? A little bit checking our work. So great job. Can I have Miss T, can you read our answer for the bottom?
Yes. Now Rudy and Omar have 14 Pokemon cards.
So remember, don't bring Pokemon cards to school because they might fly away. We are excited to see all of your strategies, and remember, you have lots of opportunities to use different number sets and try different strategies to see which strategy is the most efficient. Bye, boys and girls. See you later.